WLD101 111, weld drawing 111-01 pad plate. It's a surfacing weld, building up a worn part. 1/8 inch E6011 is our electrode of choice. Alternating current, power source, a little Lincoln AC225 buzz box, 85 amps. Materials 1/4 inch hot rolled, HR is the symbol for that, 836 mild steel. Let's get right on to pass 1, utilizing a whip and pause technique. Gonna notice that we're holding the electrode somewhat inboard on the part. We're again starting on the right side of the part, moving to the left as you're looking at it. We're going to hold into the middle there, and then as we come back, we're going to hold back and let it fill to the edge instead of actually welding on the edge and eroding it and blowing that edge out. I want to maintain that square shoulder. All right, pass 2. When we move on to pass 2, we can't stress enough, make sure that you clean this thoroughly. And we're talking about power wire wheel, hand wire brush. Make sure that the electrode covers about 50% of the previous pass. And we want to do that to assure that we have good stringer bead overlap. And that is what this assignment is actually doing. It's doing 2 things. It's learning us a little bit about the sequencing of stringer beads and actually how to build a padding plate. Notice that the electrode again is covering about 50% of the previous pass. This little alternating current machine, we had some not difficulty with it, but we were really pushing the capabilities of that machine as far as the duty cycle goes. And you'll notice as we get towards the end, we struggle with it a little more. Something to think about when you're looking at a power source, is it going to be able to handle everything I want? Again, we're welding with a $75 machine here. Pass 3, same rules pass 2. Keep in mind, while practicing a weld that adds material to a worn surface, continually focus on overlap. Again, this is a stringer bead exercise, and we're going to see the importance of that as we get into multiple pass welds down the road, especially that 13610 T weld. Lighting off on the edge. I'm going to come back. I think I was running a little low on Dutch Brothers here. I had a couple errant pullbacks where I actually didn't get my 50% overlap. And we notice again, 6010 and 6011 have the tendency to have excessive spatter. That's just the nature of cellulosic flux electrodes. And as we're going through that, we're going to notice that that's why cleanliness is so important here. In the old days, the old timers used to tell us, oh man, you can just burn that slag out. Well, we want to make sure we remove that slag. We want to remove all the spatter that we can and try to keep this surface as pristine as possible. Because again, theoretically, in the future, we're going to be running another layer at right angles to what we're doing. So, potentially we need to make sure that's clean. And it's super important as we get into the stringer beads. We're going to fast forward to pass 6. Again, clean each pass thoroughly. Any residue is going to inhibit proper performance of the part. Again, laying down that second layer, if we have a lot of slag buildup underneath that first layer, we're going to have issues. Had the editing software lock up here, and I just didn't have time to fight through it. But we're going to see that past 6, again, we're getting closer to the edges. We're looking at it on the left. And the machine is starting to struggle a little bit, and we're going to see that because our weld pool's not wetting quite as much. I ran this all in one setting, so 7 welds, probably a good solid 20 minutes of welding on a machine that has a 20% duty cycle, getting into the edge of what its capabilities are. But again, that $75 machine did perform. It built the part that we needed, and kind of gives us an idea of when we're looking at machines, if we don't economically have that big pocketbook, we can actually set on that deal. Final pass. Everything goes right, it's going to be your last assignment. If not, and again, don't get discouraged if you come to myself or Anthony and we go, hey, run it again, because practice makes perfect, and this is an actual skill set that is developed by practice. We're going to tell you a million times it takes 21 days to develop a good or bad habit, so we're going to take a few days to figure this out. Notice that I'm holding a little bit off the edge. I'm going to try not to really roll that edge too badly. Couple spots I came up a little short. You're going to see again that the machine is struggling somewhat. It's sputtering a little, but it did do the job, and I was really pleased with the fact that we could demonstrate that we can run this kind of apart with a $75 machine. It gives hope to all those of us that are not financially well off that maybe we can use some of these. Finished product. If we're performing the actual surfacing procedure, we would be running as many layers as needed to achieve the desired elevation. The layers would be ran at right angles to the previous layer, so we'd actually be kind of waffle stacking these. And there's our part. Again, it's not really excitable for me because there are some flaws in it. We have some voids, but for the machine that we did it with, and for what our parameters were, was totally acceptable. We would accept this weld for a grade. Okay, and those are the things that are important, is to make sure that the parts are acceptable and they are gradable. What we learned? Well, 60 series electrodes spatter a lot. Electrode position is critical. Cleanliness is vital. Don't overheat the workplace. Follow all those parameters. You know, we talked about rod angle and arc length, amperage, and actually welding is fun and really a good way to get started with this.